Okay, cool. So 2-4. Number 9. So there's data set 22 back in the appendix. And they ask you to use the weights of discarded plastic. There you go, cool. And data set 22 is humongous, right?
Yeah.
Use the weights to construct a stem plot, okay. So what's up?
I don't understand exactly how the rounding works, because like in the back of the book it's saying, like, for instance, if you look at stem 5, then the leaf for it is 2, and it's 5.28 is the plastic, but apparently you round, and I found that in all cases with the stems and the leaves you round down no matter what the number is.
No, in fact,
well that's
they
how
truncated it. Yeah, they truncated in the back. So a lot of times they'll use like computer software to create a lot of these things. And depending on what software package you use, they'll truncate it or they'll truly round it. So I'd rather truly round it. In fact, to tell you honestly, I'd rather, this would be huge because the data set's so big. So if I really wanted to keep, just to make an argument for why I want to do one of the two, round or truncate. Truncate means just cut. So 5.28 would become 5.2, which should kind of irk us a little bit.
Yeah, that's what they did.
But if I did do like 28, 31, 41, I mean, it's such a huge set of data, I'd have to turn my paper around and maybe tape another one on it just to be able to get through this list. So it sort of makes sense to round these to 1 decimal place.
Yeah.
But if you don't, I understand, because they never said to round it. You really probably shouldn't. The only reason they did, and they truncated, which is bad, they should really truly round it. The only reason they did it is because just to cut down on the space it's going to take.
Yeah.
Yeah.
Well, if your stem's like, say, 5.2, and it won't be 3 and da-da-da-da-da.
So what he's asking is 5.28. They made it 5.2.
Yeah, I'm saying that. Can we make a stem of like 5.2 on the left side and just 8 and whatever 5.2, whatever's on the right?
If it made sense with what would be here, but that would make sense with what would be there. Because I think the data, so the data we're looking at for these plastic weights, and data set 22 is on page 640. So it's like 0, 1, 2, and if I wanted to make these the first 2 places, then this would be huge. So instead of having huge in this direction, you'd have huge in this direction, which is sort of getting away from what this wants to do. It wants to give kind of a compact, quick visual of the data. So if I did it that way, I'd have way too many classes then, right? Because one thing I can look at is each one of these would be sort of a class. So then I can do this and look at my histogram sort of. So what they did was they decided to take it to 1 decimal place, so the shape would be the same. And you just kind of sacrifice knowing what the real, true, whole data point is. You guys?
Is that half the point of the stem plot data, that the data itself is still preserved and easy to see in it?
Depends. The real point of a stem and leaf plot is to sort it quickly and to get a quick visual. So the way that they did it, they wanted to preserve the visual while keeping the other things easy. So if you guys don't round at all, I'm cool with that. You're probably going to have to turn your paper over so you can actually fit everything in there. You with me? Because if you try to put 2 digits in here, it's going to have to kind of go out for a distance. Yeah?
Is it alright if you just like separate them with a comma? The 2 digits?
Yeah, it's not terrible, but you shouldn't be any commas in there. It should just be spaces. But if you put a comma, I understand.
Okay.
That's fine.
So for instance, there was ones that were like 2.96, so would you just make that in the stem of 3 and then add another 0?
Yes, I will. Yeah.
Okay.
So that's
I thought
preserving
maybe
the.
that was why they were doing that, was because they didn't want you to add more stems to, or more.
And there's really 2 schools of thought, and I fall on the side 3 is closer to my actual data than 2.9 is.
Right.
So I'd rather do that, or make this higher resolution so you can keep these. But then that's.
Well, if it's 2.9 and anything under 5, and if 2.94, then it would still be 2 and 9, right?
Exactly.
Yeah.
Cool.
Okay.
Yeah.
If we rounded down like the flipped it, instead of rounding up, will we get marked down for that?
No, because I understand if you look back there and you see and you think you're supposed to, I understand. But do you guys understand? I know why that school of thought exists. Because they want it to stay in like the 2 STEM. 2.96. They want that to be in the 2 STEM.
Right.
But that data point is closer to 3 than it is to 2.9. So if you do want to cut this down, you should do it correctly mathematically. Right? Then it's truer to my true data. You guys semi with me?
Yeah.
So they want 2.96. So if I have 0, 1, 2, 3, they want that to be here. But I'm not sure if I can explain. It's not even that big of a deal, to tell you honestly. But putting it here, they would say, well, that's bad because then it's sort of in the wrong place. But I'm saying your resolution isn't enough to capture that anyway. So who cares? You're going for a quick visual. Make it what it should be. Make it 3. Right? Because if there's a lot like that, it should be more evident that things are tilted in the 3 direction. Because that's what my data is doing. If there's 2.96, 2.98, 2.93, that would go to 2.9, 2.99, 2.98, 2.99. If there are a bunch of them, then it should kind of be tilted towards 3. The visual should be in this direction. But if you did do this, because you're like, what the hell? I guess I'm supposed to do that. I understand. That's cool. But I always forget about this one problem, that they do that in the back of the book, and I think it's because whatever software they used to generate it real quick just truncated it. All right, you guys, that's a great one to start the morning off. The hell just happened? All right. Any other questions from homework?
Yeah, just that one.
You could catch up with who just came in. Anybody else just come in and get your quiz back?
I think so.
Do we turn in corrected homework? No?
Yeah. Yeah. Oh, yeah. All right. Just a reminder, guys, you can make corrections to quiz 2, just like any other quiz. The way it works, if you're getting closer to this test, is if you make corrections on the quiz and get them all right, and then you do better on the test, I'll actually make your quiz grade become the test grade. You with me? So let's say you get a 20 on the quiz. You do all the corrections, get them all right. You missed 80 points, so I actually add 20 on, so you get up to 40, which is yay. Right. But then you get like a 70 on the test. I'll make your quiz grade become 70. Oh. Neato, Jeff. Now only do that with one quiz. And I either do that with the lower quiz grade or the quiz that you actually got corrections right on. You with me?
Do you do that
Got it with
every
me?
test, or only, do you do that every test? Or
Every test.
Okay.
So whatever next quizzes we take, the next test will affect those quiz grades, whichever one. Yeah. All right. Too long, didn't understand, do the corrections, you'll be better off. All right.
And we turn those in on the day of the test,
Day of the test, that's right. Homework corrections are due when?
right?
Day of the final, I love it, I love it. Okay. Today, we're gonna go pretty quickly through 2.5, because I'm gonna leave 2.5 up to you guys for the most part to read through. It's another, hopefully, common sense kind of section. I'm always hoping. And I really need to get into chapter 3, because that's the teeth. That's our first real teeth chapter. What the hell do I mean by that? Chapter 1 was no teeth. It was all definitions. Chapter 2, you can start kind of getting into it. You can make a histogram, but it's still not really teeth. Chapter 3, we're going to analyze the hell out of data. Get the mean, get the mode, the median, the standard deviation, all the weird shit. We're going to calculate it. Chapter 3, you're going to have to do a lot by hand that I want to say right now, and I'll remind you, once we're out of this next test, once we're out of chapter 3, I'm not going to make you do it by hand again. So in the homework, if you don't do it by hand, I will make you redo the whole thing. Because you've got to get that experience of doing it by hand, and my compromise is I won't make you do it again after this next test. So do it now, so you don't have to redo everything. Okay. So section 2.5 is really kind of all about how to lie with statistics. Is there an eraser in here somewhere? No, okay. Let me see one of those high-tech.
That's probably why it's required for putting this in.
I appreciate that. That's good. Stop. Somebody's Mickey Mouse. Kind of. All right. Well, neat. That's strange. Did I steal it? All right. Well, that sucks a lot. Poor Jeff. All right. Let me lecture a little bit. Let you guys do something, and then I'll go grab some towels or something. So 2.5 is really all about. Who can tell me what's wrong with this graph here? So why does that distort things?
I think the bars are supposed to be really next to each other instead of like.
No, it's okay. Why is it okay for the gap to be there? This is a bar graph. This is not numerical data. This is qualitative. So that bar is okay. It's not really a scale. So people aren't going to think I'm skipping anybody because I've got them very well defined here.
Because it looks like even though it's 60 and 50, it looks like there's only half as many women as there are men.
Yeah, exactly. This could be, I was thinking in my head, this is kind of like the amount of salary they get, or this could be numbers of people that went somewhere, number of people that voted. And so he's saying, women aren't getting out there to vote. Look at that, there's more than almost twice as many men. What makes it look that way? How could I correct this? The scale sucks. So you'd be surprised at how often this kind of thing happens in magazines and newspapers, on news. They do this thing and people don't even, they're like, in their head, they don't even think about this, number one. They don't even think to look here to make sure that's not happening. And if they notice it, they're like, well, they didn't want to start at 0 because there's not much going on. But then that overstates differences then, right? So if I really made this correctly, start at 0, 10, 20, 30, 40, 50, 60. Now men would be here and women would be there. You can still see the difference, but it's not overstated. Okay, cool. So that should be semi-obvious, especially now that I've pointed this out, but be able to look out for that. It's crazy how often that kind of thing happens. Secondly, what if, I keep looking for it because it's like automatic. Another thing that I personally hate and that this section talks about, which I like, is if I was talking about, let's go back to men and women and how much they make. Let's say women make this much money. They make $50,000 at some job, and men make, so they make this side 60 and not 50. Well, that's definitely overstating, John. It's not gonna make it crazy. So they make a little cube like that. Blah! Right? So who knows something about if I have a cube that is 1 inch on each side? What's the volume of that cube? Not something you'd expect us to talk about in statistics, but 1. Right? 1 cubic, whatever the hell. Right? Now, if I double all the sides, which I've more than done there, but what's the volume now? So this does not represent a multiple of 2. This represents a multiple of 8. So you don't want to use 3 or even 2-dimensional figures to represent 1-dimensional data. Money is 1-dimensional, right? I can't use 3-dimensional figures to represent that because it's going to overstate it. It's going to make people go, whoa, crap. Or they use little oil barrels to represent how much oil people make and so forth. And people, what, really? That's terrible. And it's overstating it. It's making it look worse than it really is. Yeah.
What if men made like $400,000 compared to like women's 50,000? Then would it work? Like
if you made it truly volume comparison, which people normally don't. But still, even then, you want to do it like the bar graph. Then there is a real difference. So you want everything else to be perfect so that people can't complain about anything except the difference.
Yeah.
Right? They can't say, oh, you're making it look some different. No, it really is that bad.
Yeah.
Yeah.
What's wrong with using oil barrels to show the production of oil?
Because again, it's a three-dimensional figure, so it has the same problems that the cubes did. Plus, it kind of ties into the idea, so it kind of, if you already feel bad about how much oil is being used, using an oil can to illustrate that kind of ties in with your emotion.
So if they had it like, they had like 1 barrel of oil represent a million barrels of oil, and they just stack them up on each other to show how much oil production was consistent in a day, would that be accurate?
Yeah, that's better, because it sort of is mimicking rectangles then, right? The height would represent truly, but it still has a three-dimensional thing which isn't really coming into play, but what's more important there is it's tying into any emotions you have compared with oil. It's not making it purely, here's the data. Okay. Do you follow what I'm saying? So it's sort of like if they had fatalities and they had little dead bodies stacked up. I mean, that would sort of tie into our emotions, like it just did, see? All right. By the way, it's just to get you ready, because there's a lot of morbid examples in this book, so just be ready for a lot of death and dismemberment stuff in this book about statistics of things like that. Okay. So that's really, on these problems, they'll give you a setup, they'll say, tell me what's wrong, and then they'll say, do it again right. So that's what this chapter is all about, this section. So I don't think that should be a huge problem, so we'll see. So try that out. Now let's get into the real stuff. Let's get into chapter 3. I'll tell you what. Oh, well, my hands become all purple and black. Let me give you something to do, and then I'll be right back with something for me for this board. Oh, here. Find the average of these. Do you guys see that okay? Yeah. I should have written it better. I'll be right back. If you need a calculator, by the way, there's some up here. We're going to be using it a little bit more here in a little bit. So we'll borrow one. So to tell you honestly, I almost don't care what the answer is, but what is the answer?
71.1.
Who is it?
71.1.
71.960? 916? Okay. Somewhere around there, right? Alright, so hopefully everybody got close to that. Crowdsourcing is promise, right? What's more important to me, and very often when I ask somebody to tell me in English, some people can't quite do it, but if I ask you to do a problem, you got it. How did you get there? What did you do? So an average in English, the average is add them all up and divide by
The amount.
good. How many there are? Okay. Groundbreaking. But what I want to show you is now, this is going to be, this is a very important section because it kind of gives you relatively simple things that we can do already coming into the class. And it uses that as an opportunity to introduce the symbols. So remember what I told you about this class. There is barely any algebra in here. There's no word problems. So what truly gets people confused and making mistakes are the formulas and all of the symbols and what they mean. So this is us taking baby steps into these symbols. So first off, and this will be, let's say this is a sample of grades from something or other. So the symbol for the average of a sample is X bar. So you read this. The symbol for add something, right? The symbol for add, and of course the official word for add in mathematics is the sum, right? So they use the Greek letter S, the capital Greek letter S. Anybody know what that might be? Sigma, I like it. So they use the capital Greek letter S. So this is uppercase sigma. We'll see lowercase sigma come in later. That's where I desperately need you to stay with me. I'm not going to require you to be able to recite the Greek alphabet, don't worry. Right? But when I say sigma, I want everybody to kind of with me what it is. I don't want to have to stop and explain again. It kind of makes sense. Let's use the letter S. Very creative math people, but what the hell? What's So add. This symbol by itself never really means anything, truly. It's sort of like a square root symbol. What is it missing? It's missing something in it, right? So add what? What would be? All the data values. So what single symbol could I use to represent all of these? Beautiful. Now you see why this is X. The bar means average. Love it. So add up. Right? Okay. And then divide by how many there are. So divide by the number of data points. So divide by the number of data points. So what letter am I telling you we're going to use there? Yes, F. Okay, so there's our first official formula. So this is why people hate math, is because it is shorthand. It is another language. Math people, we do not want to write all this crap out. Screw that. So we made up some shorthand. You got to learn it so you know what the hell we're talking about. So then you can use that language too. Very simple idea of average. You guys didn't have to have me teach you anything to be able to do this. But here's what it looks like in statistics speak, in mathish. Okay, cool. So, real quick, if I had Here's my, let's say I have this data list. What would this be? Careful now.
29.
So what is this telling me to do? Add these up, right? So what's, yeah, so 11, 30, exactly. 11, 11, 22 plus 8, 30. How do you think I would do this? Would I just do 30 squared? What do you think? Let me put this in connection with, this is one of the most evil things in algebra. Remember the whole thing about what's this and what's this? Remember that? It's back. Shit. Which one of these is negative? Either one of them negative? Yeah, the top one is negative. Because what's 2 squared?
4.
And then you just put a negative in front of it. What do you do? What's this squaring? The negative 2. 2 negatives cancel, so that's positive. Here, what's being squared here?
The entire value.
The sum of x, which we know is
30.
30. So this is 30 squared. What's being squared here? What's the order operation say? Do I do exponents first or do I add first? Exponents. So what do I actually need here to help me out?
Square all square.
Yeah, I need a list of x squares. So what I'll do is I'll say, you can cover up the sum symbol, and you can see what's right next to it. You better make sure you have those so you can add them up. Because what's coming down in our future is there's going to be a few semi-large formulas with these symbols running around in them. And you have to know, what the hell do I put there? What am I adding up? Do I have what I need? Right now I don't. So of course, what do I put here now? 16,
49, 121.
11. And you add that business up, 70, 80, 250? Yeah. Sweet. All right, how are we doing so far? I want to get that. I figure this is the right time to do that. The minute you see the symbols, I want to show you how they could possibly be used, because they're going to be used exactly like this very soon. Cool, cool, cool. Okay. So real quick, since I said that a sample mean is x bar, right. Population mean,
Average was X bar.
oh yeah, sorry, mean is another name for average. That's my fault. You know, that's my language now, so I got to remember what words we all don't know yet. So mean is another name for average. Math people like 4-letter words starting with M. For some reason, you'll see why. Math. So they didn't like the word average, so we made it the word mean. And to tell you honestly, I mean, that's obviously not the truth. Right? But the reality is there's several things that could be called average. To tell you honestly, what we think of as the average generally is the mean. But there are other things that could be called average that aren't the mean. So yeah, that's why we have this word, to make sure that we're all talking about the same thing. Population mean, now tonight we got a Chargers game, so I always think about, like in the Super Bowl, how do they make it seem really official and really like Super Bowl? You know, whoa, it's really official and it's like big time. What do they do with the number of the Super Bowl? Roman numerals, right? And they're normally some kind of rock formation that comes falling down on the screen. Super Bowl, boom. So for the population stuff, I want to do sort of the same thing. It's not just a sample; it's everybody. It's the whole freaking population. It's population. So we're going to use Greek symbols for the population. We're not going to use our letter X. We're going to use the letter. You'll love this. Mu. It's not an M. It's a U with an extra leg. But if you put an M, I'll understand. Don't confuse it. It's a U with an extra leg, right? And it's the Greek letter mu. So it's like a French cow, right? Mu. There you go. I appreciate the laughter. Pity laughter, yeah. He's trying. Now, one thing I don't agree with the book, n should always mean the size of the thing you're looking at. So I should still use little n, but the book uses big ass n. You can see why. It's a population. So the book uses big ol' N. I very often will just use little n everywhere because it means the same thing everywhere, the number of things you're looking at. I don't care if you're looking at the population, it's the number of things. But the book uses big ol' N. Cool. How are we doing so far? Okay, good, good, good. So it's going to become crazy important later in the book. If the problem uses this symbol or that symbol, you might have to do one of two different things. Because this will tell you it's a sample they're talking about, this will tell you it's population. So they might be two different things you got to do. So that's the mean, what we think of as the average. That's what that is. The next, and this is really, this whole section is all about what's called measures of center. And let me show you, so the first thing we did here is the mean, right? So x bar or mu. Now, let me ask you a question. Whenever you read the paper or you see a news report or something about income or about, especially here in San Diego, home prices, what do you think would be wrong? And they don't do this. They never give you the average home price. If you ever looked at an article about home prices are recovering and all that, they never say the average home price is this. They use something else. And when you do salary, you do the same thing. Yeah, the median. So a quick example would be if I was going to a company and I said, how much can I expect to make here, working here? And let's say I've got 4 people that work there right now. I got somebody making $40,000, somebody making $42,000, somebody else making $49,000, and then the CEO making $500,000. Now, if I tell them the average of those, on average, people here make this much. They'd be like, holy shit, sweet. That's not realistic. That's not really capturing what the data is trying to say. And why do you think here the mean is really bad to use? Obviously, it's because this guy's an outlier. He's pulling the average up, the mean. He's pulling that mean up. So the median is exactly what it sounds like. The median in the road is the part that's in the middle. Now here's an interesting thing. I chose 4 numbers here. Not on purpose, but I'll go with it. What number is in the middle?
42. 49.
None of those numbers are in the middle, are they?
The average.
I like it. So the number that's in the middle here is the number in the middle of those two. Whatever's right in the middle of those numbers is definitely in the middle of all the data. So the median is always the number that's in the middle. Now what else has got to be true? I sort of did this as I went. I put it in order. If it could be any order you want to, then the median wouldn't mean anything. Because I could put whatever number I want to in the middle then. So it's got to be in order. So this is the number in the middle when ordered or sorted. So what is the average of 42 and 49?
45.
And the symbol we use for the median is X tilde. Right? It's not as major as a mean, so he doesn't get a nice straight bar up there. He's got the leftover bars that have been around for a while. Got a big old kink in there. All right, Jeff. Not everything's got to be a story. All right. How are we doing so far? I mean, this isn't anything too major, right? So another example. What would the median be for that?
472.
So nothing, you have to change it first.
I know. So don't say 7. 7 is actually the highest number. That would not be right. So of course, Jeff, so we'll leave them. You got to put this in order. So if you sort it, what do you get? 1, 2, 4, 6, 7. So what number's in the middle now?
4.
That's right. Oh, 4. 5 numbers. There's definitely one in the middle. Cool. Whenever I'm upset in the class, I say, oh, I didn't.
How did you come up with the 4? The top one.
Here.
Yeah.
So here there were 4 numbers.
Yeah.
So there is no number in the middle then. There's 2 possibilities. So what you do is you average those. So if you have an even number of data points, the median is the average of the 2 in the middle. Because whatever's right in the middle of those is definitely right in the middle of all the data, right?
Yeah.
The median's got to be right in the middle of all the data. If you don't have a single number that's in the middle, you average the 2 in the middle. Now that's crazy middle. The number in the middle of the 2 in the middle is crazy middle, right? It's definitely the middle of the whole data set. If there is a number right in the middle, cool, it's that one.
So you add together and divide by 2.
Exactly. So to get the number in the middle of any two numbers, you average them. I like it. Yes, sir.
So if you had another really high outlier, like if it was like 600 or whatever for that one, would you still, would you go with 49? Like, would
Yeah,
you
well,
still
49,
count
if you had another one, 600,
Yeah,
then 49 would be.
You just go with 49.
Yeah, now
Even
if you
though-
added on 600 and 700, well now it's sort of like, you know, you can't follow what I'm saying. So if you add one more guy on here, get out. 500 and then
So even though
600.
it's an outlier, it still counts towards the total.
That's now the median, right?
Right, yeah.
Now, to me, an interesting question would be, what if I add on even another one, 600, 700? Now the median is kind of, but to tell you honestly, if you have 3 people making low and 3 people making high,
You have a chance to lie.
I don't know what the hell's going on there. Do you flip a coin when you come in? If it's heads, you make 28,000. If it's tails, you make 480,000. Let's go. Right? You're like, I'm not going to use one of your coins. Let me use mine. All right. You're like, man, the trick always works. You guys kind of with me?
Yeah.
I mean, now, with all of this stuff, I mean, I definitely want you to understand, you got to learn the procedures, but every single thing we do in here, you can step back and adjust it for your situation. So obviously here, if there were 3 bosses and there were 3 underlings, whatever I call these poor people, one of which is me, and somebody's coming in going to be an underling, then all I can do is kind of ignore those and just look at the average of those. That's another option. You with me? And that's not being dishonest. That's saying that this doesn't really represent you. This represents you. You guys kind of with me? So that's not, you can't always just throw out data when you want to, but in this case, if somebody's coming in, he's going to have a job like these guys, then the average of these guys would give him an accurate impression of what he's going to make. Okay, good. So you can adjust. Any situation you're in, you can adjust. You got to explain it if you're going to do a report and explain what you did, but you don't have to follow lockstep everything we learned in the real world. Now in here, most of the situations are going to let you follow lockstep, so you can just get used to the procedure. Okay. So even that's not enough though. So we have the mean, we have the median. Shoot, that doesn't want us too tight. There's another one. There's actually 2 more that we could use.
No.
Exactly. So the next one is the mode. There's 2 reasons for this guy. If I want to know where things are centering, I kind of want to know where things are clustering might be another way to think of it. So I could look for my modes. So if I had, for example, if I had a distribution that looked like this, where are things centering? I could find the average and that would be in there, but that doesn't really give me a good feel for where things are centering. Where are things seem to be centering is here and here. Those are what we call the modal classes. Those are the 2 modes for this. Because those 2 represent the ones that have the most. Right? So another word for mode. It's kind of nice. Mode and most go together. Okay. So taking a step back from histogram data, let's just look at a list of data. How do you figure out the mode? Okay. I'm giving you kind of evil examples this time around, but what would the mode be here?
Almost 9.
It's not the highest. It's the data point that occurs the most.
8.
8. Like, I do get people that tell me 7 is the mode just because there's 2 of them, but there's a definite winner here. 8 is the winner. It's a single mode, right? So very easily I could say, what about this situation?
Four and 7.
Yeah, beautiful. You got a tie, so you got what's called bimodal data, right? So this would be officially bimodal. Like bicycle has 2 tires, so bimodal has 2 modes. The modes would be 4 and 7.
Is there a symbol for mode?
I appreciate that your question. No, there isn't. This is, for some reason, I had never made a symbol for mode. I don't know what happened. Whoever's job that was kind of never did it.
There wasn't an extra Greek letter floating around.
No, I guess not. They're like, oh, we used every one up. But if you go further in math, you realize they use them multiple times. You're like, what the hell does it mean here? Shit. We could make up our own. Maybe a little bowl of ice cream. I always think of pile of mode here, right? There's a mode symbol. Lots of ice cream in there. It looks more like.
But then that circle
soup.
is also a symbol for something, right? With the line through it.
Oh, you mean like this?
No, the one with the line through it. It's like
Yeah.
yeah.
So we'll stick with just mode. All right. So mean, median, mode. Each three of them have particular reasons. Median, I know, sometimes is better than mean. Mode sometimes is more important than one of these two. I want to know where things seem to be clustering. Plus, the mode can be used for qualitative data. With me, what the hell does that mean? Data that is not truly numerical, right? Everything else I got to be able to add, subtract, and take the average and all this kind of stuff. Mode is just what's the most. So if I went around and I did a little bar graph of what type of car is out there, I can see which type of car is out there the most. Do more people have Hyundais? Do they have Fords? Do they have whatever? You with me? So it's another reason why mode is important. It's the only one that can be used for qualitative data. Okay. And the last type of measure of center. There's a little mouse in there that's dying. Really, then you can use it. So, mid-range. Well, I escaped from a snake in the science. Mid-range. So what's your gut reaction to mid-range? The number that's in the middle of the range. I love it. That's exactly what it is. So this one is, notice how the mean is the only one that takes all the data into account. They all get fed in. The median only takes the one or two right in the middle. So median is more position dependent. It doesn't care about the outliers at all. And the mode just says who occurs the most. It doesn't care at all what the numbers are, just which one occurs the most. The mid-range only cares about the high and the low. Doesn't care about what's going on in the middle. So if I had data like, I keep starting at 1, 11, 14, 17, 19, 20, 52. First off, what's the range?
11.
Yeah, so it'll be high minus low, 52 minus 11, 41. Now here's where you got to be careful. The mid-range should be the number that's in the middle of the high and the low. Right? So here's where people always make a mistake. The mid-range formula does not have a minus sign in it because to find the number in the middle of these two, you take the average, and the average involves adding. So the mistake everybody always makes is they do high minus low over 2 when it should be plus. You guys take the average of the high and the low to get in the middle of the high and the low. How we doing? You see how that would get like another sense of middle? In the middle of the lowest and the highest, it's another way to get the center of the whole data. You guys doing all right? Yeah, I like it. Good Lord, Jeff. Freaking centers are there. So what would this be?
31.5.
Yeah, you get 63 over 2, 31 and a half. Cool.
Is it always divided by 2, or is it
Always.
how many, like if there's two numbers that are the same, does that matter?
Doesn't matter because it would just be its high for the high. The high is still that number. So if I had another 52 up here, that doesn't change any of my work.
Oh, okay.
Yeah, that's a good question though. But it's still, the 52 is the biggest. Which one? I don't care. Can't really tell them apart. Okay. So, let's see.
What data is the mid-range used for?
Could it be non-numerical? No, because you have to add and divide by 2, right? So it can only be used for quantitative data. Right? Cool. Mode, that's like I said, mode's the only measure center that we're gonna talk about that's used for qualitative data also. Okay, so do this for me. Find the mean, median, mode, and mid-range for this data. What I normally do in the test is it just takes samples of your quiz grades and have you guys calculate this stuff for you. Now here's what I want to see on a homework or on the quiz. I do want to see this. I want to see the formula. You don't have to show me this because I mean I know we all know how to add, calculate add for it, but I want to see you filling it into the formula in the right place. You know how to take the average, this shouldn't be a big deal, but I want to get you used to these symbols. What do you get for the sum of these?
164.
164?
Yeah.
Is that cool? And then how many are there? 7. So what'd you get for the average?
23.43.
23.14?
43.
43? Is that what everybody else got? Okay. All right, good, good, not too bad. What's the median gonna be? Yeah, there's a definite winner there, right? There's 7. There's gonna be something right in the middle. So the median is 16. Any mode? No mode, that's fine. And what's the mid-range gonna be? Which you did?
26.
Yeah, 50 plus 21, not 50 plus 1, 50 plus 2 divided by 2, there's your 26 only. So I want you to notice all the different measures of center. Why is the mean higher than the median? They're not officially truly outliers, but they definitely kind of don't follow the pattern. This is sort of down here, but there's more higher. So it's going to pull the mean up. Cool. And so the median, whenever the median is smaller than the mean, it must mean that outliers or just relatively larger data points are up here. If it was the other way around, there'd be more down here. Cool. And what about the mid-range? Is that close to either one of those?
Close to the mean.
Yeah, it's closer to the mean, but it's even higher than the mean because, again, it took into account one of those possible outliers that the height that wasn't the same
Would
as
you
all the rest.
consider that 50 an outlier?
We'll actually get a more, we'll get a precise way to measure if something's an outlier or not. But it definitely doesn't follow the pattern of the rest. So I'd say this and these are candidates for outliers, and in a couple more classes we'll actually have a way to test it to see if it is an official outlier. Outlier.
As you mentioned before, if you neglect this, if you ignore 49 and 50, what would be the median of the other?
Oh, if you ignore these two,
Yeah.
yeah. If you ignore these two, the median
The median, when you're doing the median here.
The median
Uh-huh.
would be 15 now. Right?
Only 15?
No, because now it'd be 15 in the middle of those. The median has to always be what's in the middle. So if you sort of ignore those two, then the median is 15. So it's interesting to note, and this happens very often, especially with large data sets. If I take out a few data points, the median doesn't really care that much. Whereas the mean, if I took those out, the mean will change a lot. You guys with me? That's why the median is used more often when there are extreme outliers, but the mean is used the most in general. Yeah.
If we're asked to like remove outliers, and then when we're doing mode, and like will you still include outliers if they are in
You won't
mode?
be. There will be one case where we talk about removing outliers, and it's what's called a trimmed mean. You trim off the top percentage and you trim off the bottom percentage so you get to the core of the data. It's called a trimmed mean. There's one homework problem that deals with it. Most of what we're going to be doing is just straight up textbook definition, just to get used to it.
But that won't ever affect the mode, right? Like removing outliers.
It might if the mode was 50, because there are two 50s and I took one of them off. Now there is no mode.
Yeah.
So then it would change.
Okay.
Yeah. But the median would be impervious to like trim. If I took off some on the top and the bottom, the median is still the same. So it doesn't care. That's cool. I do want to say one little thing about section 3.3. And that's we're going to start with this example next time. So keep this in your notes. Anybody know off the top of their head, the average for this is 5, no work required. The average for this is
5.
And I could tell very quickly, I took him by 2 and him by 1 down, right? But I took him and him up 1, up 2. So overall, it still adds up to 25. It's still going to have an average of 5. So what I did here was, that one down 4, that one down 3. But that one up 3, that one up 4. So overall, it still adds up to 25. You guys semi with me? Sort of? Okay. So what we're talking about, the average for all of these is the same. So the average by itself is not enough to really give me a sense of the data. If I have this huge data set, I don't want you to show me the whole thing. I want you to summarize it for me. Summarize the data set. So the mean kind of wins from section 3.2, although we know that there's times I want to use the mean, that there's times I want to use the median, and so forth. The mean sort of wins in general. It's the one we use the most. I need one more number that will describe the difference between these. The mean by itself is not good enough. The mean says they all look the same to me. What is the true difference between these 3?
The mode or the range?
Range.
Yeah, there's a couple things. The mode I could say is different. True, but the mode between these two is the same, right? But this is certainly different from this one. You guys kind of with me? Okay. So the one thing I could say, the range is definitely different, right? And let me actually cover that real quick. What if I had, stay with me, 1, 1, 5, 9, 9. Is the range different here? But aren't these two data sets different? How are these two data sets different? Mode again, I understand. It's just because I'm only using 5 numbers. I could have went to 0.9 and 1.1. I didn't want to do that. But release the mode for a second. The real difference is this is the one that's closest to its mean. All the data points are closest to the mean. This one is second, right? Which one's has the data points that are furthest away from the average?
The third one.
The last one, right? You guys with me? So I want this number to be smallest here. Because I want this number to tell me how spread out my data is. So if I know where the middle is, and I know on average how spread out the data is, those two numbers tell me a lot. Don't show me the whole damn data set, just tell me those two numbers. That tells me a lot. You guys still kind of sort of with me? So that's what I want. I want you to give me the mean, and then some other number that tells me how spread out it is. And those are a really good two-number summary of it. That's all I would need then to do some stuff. So this should be the smallest. In fact, this should really be 0. It doesn't go any.
0 for just the range, not for like.
Not the range is 0, but this number I want to use. The range, is the range good enough? No, the range doesn't see the difference between these two, right? I really want you with me here. The range is not good enough. It doesn't differentiate here. I want a number that will differentiate between all 4 of these. Where that number is 0 here, something bigger than 0 here, something even bigger, and then something even, this will be the biggest. Because this is the one that ranges the most, that I don't want to use the word range, that varies the most, that's away from its average the most. All right, so that's just, don't worry, the whole next class is going to be focused on this idea, because this idea is the most important idea we've hit yet. This number that we're going to talk about next time. Okay, so I don't know, make a big point there. Very important.
You're not going to tell us this time.
What's that?
You're not going to tell us this time?
Not yet, yeah, this is like news at 11. Something in your house could kill you now. See us at 11. No.